When you're building a multiplayer game, one of the hardest things to do is to keep players in the correct position. And now with Unity's latest network system, this isn't as difficult as it used to be. You can just use a network transform or a network rigid body, and things will, for the most part, synchronize. But if you've got a game where objects are moving fast, you might need a slightly different solution, and that's what I want to talk about today. To demonstrate what I'm talking about, I've set up a simple project here that uses 5 different ways of keeping track of network positions. We've got extrapolation, interpolation, the client network transform, network rigid body, and that client network transform with its interpolation option turned off. Let's see what it looks like as they move around. Here you can see that player 2 is moving my cubes, and one of them is moving relatively smoothly, and the others are, well, not so much. 2 of them are actually pretty bouncy and just jerk around, the blue one and the dark green. Those are the ones that are using no interpolation at all. The purple one right there is using the network rigid body, and it, for the most part, just matches up with the one that's using the network transform. But the one up at the top, the one that's using our custom extrapolation, it's actually lined up and much more in sync. It's faster, it gets to the end point and crosses these finish lines much quicker, and it doesn't have that same noticeable delay that the other ones have. And let's see how much worse this gets when we're on a bad connection. We'll use the network simulator and turn this down to 2.5G. And let's speed up our cars so they're a little bit faster. Let's put them at like a 20. And then we'll try it out and see, watch how much more this delay is impacted. You can see that the gray car or the gray box is nice and smooth, and the other ones are just jumping around and obviously way behind. Now we're going to break down how this works, but first I wanted to just quickly mention, if you're interested in multiplayer game development, check out the link in the description for the multiplayer mastery course, or just go to game.courses/MP. Let's start with the prefab. You can see here we've got a mesh renderer, a box collider, and a rigid body that is not set to kinematic, and we've got a network object. Other than that, the only component that we have is this networked car that has a few exposed properties, largely so that we can read and debug them. There is an option down here to toggle extrapolation, just so that I could have multiple car versions, and a thing that actually spawns another car when this one spawns. It says not an extrapolated car. It's really just another car object to spawn, and all of my cars are just spawning other ones so that I can replicate and see them all pop up next to each other. Those two you can pretty much ignore. You won't want to ignore the code, though. There's not much to it, and it's pretty straightforward, I think. And, well, you won't want to ignore the code, though, so let's take a look at that. First, we've got the fixed update method. In the fixed update, since we're doing this as a client-controlled or client-authoritative movement, first we check to see if we're the owner. If we are the owner, we process local input and movement, and then we send our new position and velocity to the server. It says send position, but it should say send position and velocity. If we're not the owner, then we do the extrapolation from our previous data, assuming that we have that option on. Otherwise, we do the snapping and just pop over to the new place without any interpolation at all. The do local movement method keeps things simple, just reading the horizontal and vertical axes, rotating our transform, and then setting our rigid body's velocity on the authoritative client. Then we send our position down to the server, which just forwards that information off to all of our clients so that they can do the extrapolation. The clients cache the information in a network position and network velocity, as well as a last updated server time that's going to be very important in a moment. So let's take a look at how this extrapolation works on the clients. Remember, in the fixed update, if we're not the owner, we go into this else block, and as long as we have that extrapolation enabled, we call the extrapolate movement from previous data. This is going to do 2 important things. First, at the bottom, you see that it's just going to set our network or our velocity to that network velocity that we've received so that we keep going the correct speed in the correct direction. But before we do that, up on line 66, we calculate out the estimated position. We figure out where our object should be by using our network position, the network velocity that we received last time, and then the amount of time that's passed since our last network message. We're using the network time minus last update time, and my network time method here is really just a wrapper around the singleton server time, which is cast as a float. So we've got our server time here cast as a float. If you're doing a long running game, by the way, you're going to want to leave this as a double and don't don't convert it to a float. I just did that out of habit, making everything floats instead of doubles. So we calculate out the amount of time since our last update, the velocity that we're going at, and then figure out where we think our object should be. Now, if our object is not at that position or is too far off from that position, I think right now I've got my threshold at 0.5 or half a meter, then we move our object towards that position using a simple lerp. So here it keeps it nice and smoothly snapping back to the correct position. And you might see if you're going super fast and have a big lag spike, and you maybe did a turn, maybe you're doing racing and you did a turn and there was a big lag spike. This is the kind of situation where you might see the car go straight and then kind of snap over to the side. It's not going to happen often unless you, again, hit a big lag spike. So it's a fix for that. Anyway, after that, we set the transform forward based on the velocity. This was just to kind of smooth it out. Not really the probably best way to do it, not the way that I would leave it in a full situation, because it's just going based off the velocity, but you get the idea. That's literally all there is to it. For the extrapolation, all we really had to do was keep track of that velocity and then calculate out how far away we might have gotten from a lag spike and then fix that position, which is right here. This code right here is pretty much the core of it. So I wanted to, again, do this video to show that first, extrapolation and multiplayer stuff and networking isn't really that hard. It seems a lot harder than it is, but it's not really that complicated. And second, if you're building a fast-paced game, like, you should know how to do this stuff and know this stuff exists. Anyway, I hope this was helpful. I'm going to do lots more multiplayer videos in the near future. If you've got a multiplayer topic you're very interested in, drop a comment down below and I'll see if I can cover that. And if you're really into multiplayer stuff, make sure that you check out the multiplayer mastery course. Just opened up and we'll be starting in November. There's still plenty of space left. Lots of multiplayer development stuff we'll be doing there. Building a couple different types of games, client and server authoritative, dedicated host and client hosted stuff. Building out inventory and all of the other types of things that you probably want to see in a multiplayer game. There's a link down below. You can go check it out and see the actual details. I don't want to blab on about it. Anyway, if this was helpful and you have some other multiplayer stuff you want to see, hit the thumbs up button, drop a comment down below, and let me know what that stuff is. And I'll see you in the next one. Bye.